What is rate of change? Rates of change indicates how fast something is changing. That could be the distance, volume, or pressure of some things. It determines what is changing with respect to something else. That something else could be time, radius, or height. Rate of change is used in a variety of mathematical and scientific situations. For example, finding a change in distance over time. It can also be used in finance and investing to describe the change in the value of something over time, such as a market index or individual security. Now we go to the rate of change versus air balloon. Rate of change can also be linked with the rate of change. We can apply the rate of change with the expanding size of the hot air balloon when it was about to take off. The envelope of the balloon create a shape of sphere that can show the obvious rate of change when it was burned with fire to make it denser and float in the sky.
Before we started, let's meet the group of people that have given full cooperation to finish the video. Amarul, Badrul, Afrina, Husna, Intan, and Aslan. These guys have shown great teamwork to complete this task. Now let's move to the main question.
A hot air balloon is being inflated so that its radius increases at a rate of 4 meters per minute. At the instant when the radius is 10 meters, how fast the volume of the balloon increasing? It is given that dx dt is equals to 6 meters per minute and r is equals to 8 meters. Based on the question, we are required to find the dv dt when r is equals to 8 meters.
As we all know, the volume of the sphere, which is also the volume of the hot air balloon, is known as 4/3 pi r cube. Then, after being differentiated, it will become 4 pi r squared dr dt.
After that, substitute the values given into the equation. dv dt is equals to 4 pi 8 squared times 6 and will be resulting 11536 pi meter cube per minute. So, the volume of the balloon is increasing at a rate of 1536 pi cubic meters per minute when the radius is 8 meters. The hot air balloon is rising ventrically at a constant rate of 3 meters per second. At the instant when the balloon is 50 meters above the ground, a camera on the ground is tracking the balloon's angle elevation, which is increasing at a rate of 0.05 radians per second.
How fast is the distance between the camera and the balloon increasing when the distance between balloon and camera is 70 meters?
Given dh dt equals to 3 meter per second, h equals to 60 meter, d theta dt equals to 0.06 rad per second, and x equals to 70 meter. The question asked us to find dx dt. Let's say we use the equation tan theta equals to x over h. Then we differentiate it, becoming sec square theta d theta dt equals to 1 over h dx dt. Then we make dx dt as the subject and substitute the values given. dx dt equals to h sec squared theta d theta dt on. Then we can substitute 60 as the value of h and 0.06 for the value of d theta dt, and it will be resulting the equation of 3.6 cc squared theta meter per second. At theta, tan theta equals h over x, which also equals 60 over x after substituting h with 60. We also know that sec squares are equal to 1 plus tan squared theta in the trigonometry formula. So we can consider that sec squared theta is 1 plus 60 over x squared by substituting tan squared theta with 60 over x. For the final calculation, we are using the formula dx dt equals 3.6 times 1 plus 3600 over x. While we substitute x with 70, then the final answer equals 6.24 meters per second. Thus, the rate at which the distance between the camera and the balloon is 6.24 meters per second when the distance is 70 meters.